Hello everyone, welcome to today's class. This is Teacher Simon taking you through A-Level Mathematics 9709/32 for May, June 2025. And this is part 1 for questions 1 to 6. Solve the equation e to the power of... Question 1, solve the equation e to the power of x then plus 2 e to the power of negative x out of e power x minus 3 is equal to 4. Give your answer correct to 3 decimal places. Okay, now here, this one here, I can first cross multiply. That means I will have e to the power of x, then plus, using the rules of indices, this one is going to be 2 out of e to the power of x, then which is equal to 4, e to the power of x, then minus 3 times 4, that is a 12. Then to eliminate the denominator here, I will multiply all through by e to the power of x. That means here I'll get e to the power of x squared, then plus, when I multiply it here, it will go, and then I will get a 2. Then this side I'll get 4, then e to the power of x squared, and then minus 12 e to the power of x. Now putting everything onto one side, I can bring this one this other side. So I'll have 3, because 4 minus 1, that's a 3. So we shall have 3, then e to the power of x squared, then minus 12 e to the power of x. Then when I take the 2 here, it will become a minus, which is equal to 0. Now this is a quadratic. This is a quadratic equation in e to the power of x. Okay, so I can solve this one maybe using, because this one cannot be factorized, so I'm going to use the quadratic formula. So e to the power of x is therefore going to be equal to minus b. So there's a minus, then minus 12 plus or minus to the root of b squared minus 4ac, then out of 2a. Okay, so this one gives us positive 12, then plus or minus the square root of, this is 144. Then we shall add a 24, not so. So 144 plus a 24, that one will give us 168. So we shall have the square root of 168, then out of 6. Of course, e to the power of x has to be positive, because there is no number you are going to power e with and then it gives you a negative. So this implies that e to the power of x shall be equal to 12, then plus square root of 168 out of 6. Then we shall introduce logarithms on both sides. So we shall have natural log of e to the power of x, then will be equal to the natural log of 12, then plus root of 168 out of 2. And of course, using the rules of indices, logarithms, this one can come here, and then natural log of e is a 1. So meaning our x here is going to be equal to the natural log of 12, then plus root of 168 out of 6. Pardon me here, I had written a 2. It's supposed to be a 6, but then they said we give the answer to 3 decimal places. By the way, mark this one, they said your answer, so it has to be 1. That's why I only took the positive. Okay, so this one here is going to give us natural log of 12, then plus root of 168. Then down here we have a 6. That is 1.426. 1.426 to 3 decimal places. As simple as that. Question 2, part A, expand 6 minus x. Then we have 1 minus 2x, then to the power of negative 3 over 2 in ascending powers of x up to and including the term in x squared, simplifying the coefficients of x squared. Now, using binomial expansion, which states that if you have a, then plus b to the power of n, to expand this one, you have a, then power n, then b here will begin with power 0, and then the power of b is the one that goes into the factorial in the denominator. Then you keep on dropping the power, you reduce it by 1, then that power is picked by b. It's like you're differentiating, okay? So you have n, then a power n minus 1, then b to the power of 1, then over 1 factorial. The next one, drop this power, you'll have n into n minus 1, then a to the power of n minus 2, then we have b to the power of 2 out of 2 factorial, and then we continue. Now I'll get this one here, and then I do the same. So this is power negative 3 over 2. I'll begin with that one, power negative 3 over 2, and then we have negative 2x, then power 0 out of 0 factorial, then plus. Now drop the power. We shall have negative 3 over 2, and then 1 here. When I subtract this, when I subtract a 1 from it, we shall have negative 1.5 minus 1, that's negative 2.5, which is the same as negative 5 over 2. And then this negative 2x here will be to the power of 1, then out of 1 factorial. Now, this one here is 2x. Don't write 2x here. Please take it with its sign here. When you don't do it, you're going to get wrong things, okay? Now again, drop this one here. We shall have negative 3 over 2 times negative 5 over 2, then times 1. Now this will be negative 7 over 2. And then we shall have negative 2x here, then to the power of 2, then out of 2 factorial. I'll stop there because they said including the term in x squared. So here everything is 1. And then here we shall have negative 3 over 2 times 2. Isn't that a positive 3? Yes, of x. And then next we have this one here. That will be 15 over 4, not so? Then times this 4 that comes from here. And then we shall divide by the 2 factorial, which is a 2. So this one goes. That means we shall have 15 over 2. So is it positive or minus? This is a positive, and then this is a positive. So it's a positive. Then plus 15 out of 2 of x squared. Okay. Now 6 minus x times 1 minus 2x to the power of negative 3 over 2. That one is the same as saying 6 minus x, then times 1 plus 3x. By the way, this one is continuing, then plus 15 over 2, then x squared. Now here, we are supposed to pick the terms that when we multiply, the highest we are going to have is going to be the term in x squared, okay? So what are we therefore going to have? 6 will multiply all through, okay? So we shall have 6, then plus 18, and then plus 2 reduces this one to a 3, and then that 3 times 15 gives us a 45. So plus 45x squared. Then now negative x times everything here. We shall have negative x, then minus 3x squared. And then I'm going to ignore the higher powers. Ignoring higher powers. Because this one times this, it will be x power 3, and I don't need it. So meaning our answer is going to be a 6 here. Then this is 18 minus 1, that will be 17. So plus 17x, and then 45 minus 3, that will be a 42. So plus 42x squared. The rest which are continuing, we don't need them. So this will be our answer. Then part B, set the values of x for which the expansion is valid. When you check in the list of formulae, Here where there is pure mathematics, you can see this expansion here. We have a 1 here, then an x here, then the validity here is the modulus of the x, which is less than 1, okay? So you must have a 1 here first of all. So that is what we are also going to use the other side. So for 1 plus x to the power of n, okay, validity is this x less than 1. Now, for us, we are having the main one is this one to the power of n. So 1 minus 2x here, power negative 3 over 2. Already there was a 1, there is a 1 here. So suppose we didn't have a 1 here, then we would factorize. Suppose we had a 2 here, we would factorize it out such that we get a 1. You see that? So there is a 1 here, then the validity is, now we get the part of x here, so that is negative 2x. We put it in the modulus. The part of x here is the one that is put here, right? And then we say less than 1. Now, modulus signs always make what is negative positive. So that means we shall have the modulus of 2x, then less than 1. And then this 2 will come out. The constant always comes out. And then we have this. That means we can divide all through by 2. So we have modulus of x is less than a half. So that is the validity. Or we can say negative a half less than x less than a half. That is that. Question 3 is coming from complex numbers and particularly from loci. On an Argand diagram, shade the region whose points represent the complex number z, which satisfy both the inequalities this and this. So whenever you see modular signs on one side of the equation, that one is a circle, okay? So this one here is going to be a circle. This one is z minus, there has to be a minus, and then whatever is here, that is the center of that circle, and then whatever is here is the radius, okay? So minus 3, I can even write this one as 0, then plus 3i, because it has to be a complex number here, less than or equal to 2. So this is a circle of radius 2, okay, then center 0, 3. That is that. So since this is less than or equal, then we are having that circle, a point that is on the circumference of a circle, its length from the center is the radius. Are we there? And then a point that is inside the circle, let's say this point here, its distance from the center is always less than what? The r. So meaning for this one here, what we are given, this one, we are considering points inside the circle and also on the circumference of the circle. So when we are drawing this, the circumference of the circle is going to be bold. If this one here was less than 2, then the circumference of the circle, we make it dotted, because any point that is on the circumference of the circle is its distance from the center is equal to the radius, but they have said less than. That means these are the ones that are not on the circumference of a circle, but inside the what? The circle. I hope that makes sense. Okay, then we go to this other one here. This one here. So we have a quarter pi, then less than or equal to the argument of z, put a minus, then everything is just like we did here. We shall have 1, then plus 2i. You see that? Then less than or equal to 3 over 4 pi. Now here we are going to have half lines, okay, starting at 1, 2. Okay, half lines starting at 1 2, which make angles 45 and 3 pi over 4. See, maybe I can say respectively. So one is making this angle and then the other one is making this angle, but we are looking at the region in between them. Okay, this one is 135 and then this is 45, so we are looking at the region in between them. You get it? Okay, now let's plot. So these are my axes here. After doing my axes, now I'm going to do the circle. Center 0 3, so 0 3 is on this imaginary axis here. That is the center there. And then the radius is 2. That means I will go 2 units this way, 2 units this way. So it has to pass through this one, then 2 units this way, and then also 2 units this way. That means this line here has to be a tangent to the circle, and also this one a tangent to the circle. So it passes through like that. Okay. Now to be so perfect, you can even get your compass. You do these markings very well. You have measured them and also here. So that means when you draw, you are going to see points passing through where you want them to pass, okay? The curve will pass through the points that it is supposed to pass through, not like when you just do with your free hand and then you draw something that looks like a potato, something like that, you know? So I'll get my protractor here. No, not a protractor. It has to be a pair of compasses. And then I'll put the pointer here on 0 3. Then I have to make sure that the radius is 2. Okay, but now this one cannot reach 2, so I'm going to first put it on 4 and then I diminish it later. Okay, all right, then we are going to draw that. Then we draw the circle. Of course, mine is now 4, so I'm going to diminish it, and then it looks like this. So that is how it is going to be looking like. It is passing through the 5 here, then this one is a tangent to it, even this one is a tangent, and it is passing through. This one here is also a tangent, and also this one is a tangent. All right. Now next, I will look out for the point 1 2. 1 2 is here. Then I will draw half lines. So I will first draw a line through. Then I will make it dotted because I'm just using it for reference. Okay. And then the point 1 2. 1 2 is here. Then we draw half lines. So I draw a line starting from this point, but it has to be 45 degrees from this horizontal here. Okay, so this is the line here, 45 degrees. You can even use your protractor to measure such that you be so perfect in what you're doing. Okay, so this is 45 degrees. For me, I can see the degrees when I'm drawing this line here. So that is the one. And then the other one has to be 135, which falls in the second quadrant here. In other words, we add 90 degrees here. Okay, so this is the one here. So 135 is exactly here. So when we are shading, we are supposed to consider a region inside the circle and in between what? These two lines. So therefore, this is the one here. So we shade each and everything here. And that is going to be our diagram. Question 4 is coming from trigonometry. Solve the equation 3 cot x minus 4 cot 2x then is equal to 3 for x ranging from 0 to 180. Now cot, you know it is 1 over tan. So here we shall have 3 over tan of x and then minus 4. Then this one here is over tan 2 of x, okay, which is equal to 3. But you know that tan 2x is equal to 2 tan x out of 1 minus tan squared x. So since it is in the denominator, then I'm going to somersault the denominator, it will go up. So that means we shall have 3 over tan x, then minus 4 into 1 minus tan squared x out of 2 tan x, which is equal to 3. 2 can go in here 2 times, right? And here the denominator is the same. We have a tan x here, there's a 2 here. So even here we're having a tan x which is equal to 3. That means to eliminate the denominator, I'm going to multiply all through by tan x. So here I'll get a 3, then minus 2, then plus 2 tan squared x, and then here 3 tan of x. Bringing everything onto one side to form a quadratic, we shall have 2 tan squared x minus 3 tan x. 3 minus 2, that is a 1. So plus 1 is equal to what? 0. Not so? This is a quadratic equation that can be solved, okay? Because if we have 2 times 1, that is the product, not so? And then we get two numbers, when we add them we get negative 3, that will be a negative 2 and a negative 1. So meaning we have 2 tan squared x minus 2 tan x, then minus tan x, then plus 1 is equal to 0. 2 tan x here is common, then we shall have a tan x here, then a minus 1 here, and then we just open these brackets again without wasting time. Then we ask ourselves, what should we multiply tan x with to get minus tan x? That will be a negative 1. So there is a negative 1, and of course negative 1 times negative 1, you get this positive 1, right? Okay, so meaning this one factorized will be tan x minus 1, then times 2 tan x, then minus this one here. So when I equate this one to 0, then tan x will be equal to 1. And then when I equate this one to 0, tan x is going to be equal to a half. Okay. And all of them are positive. So remember, tan is positive in the first and third quadrants. Okay. But they only need from 0 to 180. So this is 0 degrees, this will be 90, this will be 180, 270. Then by the time we come back here, that is 300 and what? And 60. So if I project an x here, and then I also bring it this other side, opposite angles are equal, even this one is x. So we shall have 180 here plus x. And then the same thing I do here, this is x, and also this is x. So to move from here up to here, that one is 180 minus x. Then this one is 360 minus x. Now, x is going to be equal to the arctan of 1, which is actually 45 degrees. Then the other one would be 180 plus 45, okay? In this third quadrant where tan is positive. But that will be going beyond 180. Then this other one here, x is going to be equal to the arctan over half. Even this one will give us the answer in the first quadrant. Remember, the mode of your calculator has to be in degrees, so shift then tan, we get the arctan of 0.5. That one will give us 26.6. 26.6 degrees. That is to 1 decimal place. Okay, so meaning the two answers we have for x here are, we have 26.6 and 45 degrees. As simple as that. Question 5 is also coming from complex numbers. They're saying the square roots of this one here can be expressed in the Cartesian form x plus iy, where x and y are real and exact. By first forming a quadratic equation in x or y, find the square roots of this complex number in the exact form. Now, if this one is a complex number, that means that the square root, okay, the square root of this complex number will also be equal to a complex number. Okay, so if we square both sides, of the equation, what do we get? We get the square root here disappearing, and then this one will be equal to x plus iy. Then we square it. This is -1 minus 4 root of 5 of I. Then we shall get x squared, then 2 times x times iy. That one will give us 2xyi. Then plus, this is iy. Then when we square it, we shall get y squared, I squared. But you know that I squared is always equal to negative what? -1. So meaning here we shall have a -1. Okay, I mean a minus y squared. I squared is always equal to -1. Now, meaning if I can separate the real from the exact part, so I will have x squared minus y squared, then plus 2xyi. Now what we do is to equate the real and imaginary parts. So what do I mean? This is the real part here. It will be equal to this one here. So I will say x squared minus y squared is equal to -1. And then the imaginary part here is this one here. Okay, then will be equal to 2xy. So 2xy then will be equal to -4 root of x. I can say y is equal to, -4 root of 5. Then we divide by the 2 of x. Okay, that means y is going to be equal to -2 root of 5 over x simplified. So this simply implies that we shall have x squared. Then where there is y, I will put this one here. Okay, so I will have -2 root of 5 over x. We square that, then it's equal to -1. So here we shall have x squared, then minus, when you square 2, you get a 4, then 4 times 5, that is 20, then over x squared is equal to -1. Now I will multiply all through by x squared to eliminate the what? The denominator. X squared times x squared, it will give us x power 4. Then minus, here we shall have 20, and then we shall have -x squared. So meaning we shall get, if this one comes back here, you get x power 4 minus, and x power 4 is the same as saying x squared, then squared, not so? Then minus, it will be plus x squared, then minus 20, which is equal to 0. You see? So because this one is x power 4, that is a quadratic equation. Quadratic means power 4. The degree of that equation is a 4. Now, this is a quadratic. It's a quadratic in x squared. Now, two numbers, when I multiply them, they give me -20, but when I add them, they give me what? +1. That will be a +5. Not so? A +5 and then a -4. So meaning here I'll have x squared plus 5 and also x squared minus 4, which is equal to what? 0. So equate this one here to a 0. That means x is going to be equal to plus or minus the square root of what? A -5. Square root of -5. And this one here, we shall ignore it. Okay, we shall reject it. Why? Because they said x and y are real. Remember? Where x and y are real and exact. So that means we are not going to take that into account. Then we shall take this one here, x squared minus 4 is equal to 0. So x squared is equal to, x shall be equal to the plus or minus square root of 4, which is actually plus or minus 2. Now, for each of the values of x, then we can get the ones of y. So for x, which is equal to positive 2, then y is going to be equal to, substitute here, you have negative 2 root of 5 over 2, and that one will be negative root of 5. Okay, that means the z value here, the first one, the complex number here is going to be z is equal to 2, and then y is negative root of 5, then of I. Remember, it is x plus iy. So that is 1. And then I also go to this one for x is equal to negative 2. Then y is going to be equal to negative 2 root of 5 over negative 2. And this one will give us a positive root of 5. So meaning my z2 is going to be equal to negative 2, then plus root of 5i. These two that we have gotten are not complex conjugates, because you are seeing, yes, this one is minus root of 5i, and then this is plus root of 5i. But the real parts are also changing in the signs. This one can only be a complex conjugate of this if this 2 here is the same as this one here. Okay, when it is all positive 2 or all negative 2, and then we see the change in the signs in the imaginary part. Question 6, part A. By sketching a suitable pair of graphs, show that the equation, this one here, has only one root in this interval. So what we do is to create a table, and then we get values, then we plot, as simple as that. So we have x here, and then y. Okay, y1, maybe it is equal to x minus 2, and then y2 is maybe equal to 2, then sine of x over 2. Okay, then we have 0, I can say pi over 2, and then pi. Those three are enough. When x is 0, then y is negative 2. And then when we put pi over 2 here, then minus 2, what do we get? Pi over 2, then minus 2. That one is negative 0.429, which I can say 43. How about when we put pi? I will take away this, and then I say pi minus 2. And that one is 1.14. Then when we come to this one, sine of 0 is a 0. Sine of 90 over 2, that will be 45. So sine of 45 is root 2 over 2. Then we shall multiply by this 2 here. Then that will give us root 2, which is 1.4. Root 2, that is 1.414. 1.414. Then when you put pi here, pi over 2 will be 1, then times 2. Pi over 2, sine of pi over 2 will be 1, then times 2, we get a 2. And then now we can draw this. These are my axes here. Here I have pi over 2, and then pi. Then here maybe negative pi over 2. You have 1, then 2, like that. So we shall begin with this 0, negative 2. Negative 2 is maybe down here. Let's just look for a point where this line is meeting y-axis. On y-axis, it is a negative 2 down here where x is 0. So, but remember, this is modulus. That means we have to reflect it in x-axis. So it will pass through this point here instead of this way, okay? All right. Then, when y is 0, then x will be equal to 2, not so? A. When y is 0, put 0 here, x will be equal to 2. Now, this one here is 3.14. Okay? Now, if I get pi and then I divide it by 2, this one will give me 1.57. And remember, we are looking for 2, so probably 2 is here. It is in between the pi and then pi over 2. Okay? So I'll draw this maybe just like that. Not so. Then after drawing this one here, then I'll reflect it here. So just like that. Okay? And that will be this one. Then let's go to the one of sine. 0, 0 is here. Then pi over 2. And then negative. Is it negative? It is 1.4. Probably it's around here. And then pi, we are having a 2. Just up there. By the way, what is the maximum of this one? This one, the maximum of sine is a 1. That means this curve can only go up to a 2. So the maximum of it is a 2, and the minimum will be a negative 2. Okay? So that means I will go like this. And then where the 2 is here, that is the maximum. So it will be like that. Now, after plotting that there, this is our y, which is equal to 2 sine of x over 2. And then, of course, this one is equal to, because this one was already the positive part of that, so it is x minus 2. And then this is the reflected one. We call it x is equal to negative, then x minus 2. You know, when you reflect a point in x-axis, the x-coordinate here, it's a negative, now is going to turn up to be a positive, but y remains, so there is change of sign in the x. No. I mean, x remains the same, but then y changes the sign. So here it's a negative, but then here it's a positive, so y changes the sign. So that's why you are seeing that we are having negative of a function. Okay, y is a negative there. So that is going to be our graph. From 0 to pi, we are seeing only one point of intersection here. That is the one there. So I can conclude and say, since there is one point of intersection, then there is one root in the interval 0 ranging from, x ranging from 0 to pi. That is that. Then part 2, show by calculation that this root lies between 1 and 1.5. Now, if I have a graph, yes, this graph here cuts x-axis. Where it cuts x-axis is our root. Okay, now here we are having an x value, and here we are having an x value. Are we there? This x value, when substituted in the function, it is giving us a value of y which is above the x-axis. Okay, y is positive. And then this one, when we substitute in the function, it gives us a y value that is what? Negative, because it is below the x axis. So that means when we get the two values of x and we substitute them in the function, we should see a change in the sign. One should give a positive and then the other should give a negative. You get it? Okay, so from what we are given here, I can put everything onto one side. So we can have the modulus of 2 here, then which is equal to 2 sine of x over 2. Then we bring everything onto one side. So minus 2, then sine of x over 2 is equal to 0. That means our function in x is the modulus of x minus 2, minus 2, then sine of x out of 2. Then we can put f of 1. Now these are small values, so calculator here, okay? Calculator must be in radians strictly. Okay, so we shall have 1 minus 2, then the modulus, minus 2 sine of 1 over 2. This one will give us a value. Then f of 1.5 will also be, this is 1.5 minus 2, then minus 2 sine of 1.5 over 2. So what do we get here? Now 1 minus 2 is a negative 1. Modulus of a negative 1 will give us a positive 1. Then minus 2, and then we have sine of now 1 out of 2. But my calculator here is in degrees. I need to put it in what? In radians. Okay, so that is 0.0411, 0.0411. How about this one here? 1.5 minus 2, that is negative 0.5. But then the modulus makes it a positive, so that means here we shall have positive 0.5. Then minus, up here we shall have 1.5 out of 2. And then we get a negative 0.8633. Negative 0.8633. You can see that there is change of what? Sign. So you can conclude, don't always leave it there. Just say, since there is change of signs, since there is change of sign between f of 1 and f of 1.5, okay, then therefore, now you write this statement: the root lies between 1 and 1.5. Now the next part, of course, we expect to find this root. And based on this equation here, we cannot solve such equations using the usual algebraic methods. So we can only use what we call numerical methods. Now here they are saying use the iterative formula x of n plus 1, which is equal to 2 minus 2 sine of x over 2 with an initial value. They have given us the initial approximate. To calculate the root, correct to 2 decimal places, give the result of each iteration to 4 decimal places. Okay, so now our x1 is equal to 1.03. What is x2? We shall substitute in here 2 minus 2, then sine of 1. No. It is that x, which is 1.03 over 2. Okay, and then what do we get? Okay, remember here, the calculator, let me repeat this one here, the calculator must be in radians. Whenever you meet trigonometric functions, put the calculator in what? In radians when it comes to these iterations. 2 minus 2, then sine of 1.03, then out of 2. So this one will give us 4 decimal places 1.0149. 1.0149. Then x2 is going to be equal to, I don't need to show the examiner again this, so just substitute. So long as you show the first one, okay? So I'll just come here and then I put 1.0149. So that will be 0281. 1.0281. Then the next one, this one will be, just come here and you put 1.02. 81. So 0166, 1.0166. Then this one here will give us, come here and you put 101, then 66. That is 0266, 0266. Then the next one, you're putting 0266, that is 0179, 0179. Then the next one, 0179, that is 0255, 0255. When do you know that you're supposed to stop? First, look at this. Correct to two decimal places, it is 1.01. This one is 1.03. This one is 1.02. This one is 1.03. The consistency is not even there. 0.0, then 2, then 0.03. You see that? So you have to continue. We have to get three values which round off to the same figure to two decimal places. Okay, so what is x8 here? So we have 0255. 0255, that will be 0188. 0188. And then the next one may be x9. 0188. That is 0247. 0247. Now this one is 0.03, 0.02, 0.02. So I've gotten these two which are having 0.02. Then I go for one more that confirms. So this becomes, at x9, these are the minimum number of iterations I can do. Okay, so this last one here has to confirm. We have 02, then 47. That one is 0195. 0195. All of these three give me 0.02 to two decimal places. So therefore, the root, okay, the root x is equal to not 0 point. By the way, it has been 1 point, 1 point. Pardon me. All through all of these ones here have been to it is 1 point, 1 point, 1 point, 1 point, 1 point. So that means here I'll have 1 point. Kindly pardon me here. 1.02 to two decimal places, and that is that. So this has been it for this first part of the paper. Thank you so much for watching. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.